Good afternoon, everyone. I'm Shubham here, and today we'll be learning about internal combustion engine. The plan of our lesson is as flashed. We'll start a lesson with an introduction of various types of heat engines, their advantages, the different parts of an engine, and we'll continue on with the classifications of engines, and we'll finally finish with the comparison of different type of engines. So coming on to heat engine. What is an heat engine? Heat engine is a device which transforms the chemical energy of fuel into thermal energy and uses this energy to produce mechanical work. The different types of heat engines include internal combustion engine and external combustion engine. Internal combustion engine is a type of engine where combustion takes place inside the cylinder. Example, all types of diesel engines, that is two-stroke diesel engine and four-stroke diesel engines. Whereas external combustion engines are engines where combustion of the fuel takes place outside the cylinder. Example, steam engines. Now, the various advantages of an internal combustion engine over an external combustion engine include higher power to weight ratio, lower initial cost, their compactness, low maintenance cost, their easiness to start, as well as they're suited for remote control starting. However, the various advantages of an external combustion engine include cheaper fuels can be used and their higher starting torque. Now, coming on to the various engine parts. The cylinder block. The cylindrical opening in which the piston moves up and down is called the cylinder liner, and when two or more such cylinder liners are held together, it is called as a cylinder block. The cylinder head. The cylinder head is made up of cast iron and is held down to the engine frame by four solid bolts and nuts, and is used to press the liner down to its seat. The different parts of a cylinder head include inlet and exhaust valves, rocker arms assembly, injector, pre-combustion chamber, the starting air valve, the indicator cock, and the relief valve. The cylinder liner are made up of wear-resistant centrifugal casting. These liners are inserted into the cylinder block to form the actual working surface for the piston. There are two types of cylinder liners, that is the dry liners and the wet liners. The flywheel. It is a large and heavy inertia wheel fitted on the drive end of the crankshaft. It stores part of the energy produced at the crankshaft in the form of momentum. Camshaft. Camshaft is driven by the crankshaft. It has accurately machined cam profile shaped according to the rate at which the valves are to be opened. It is also known as the timing shaft and is mainly used to operate the inlet and exhaust valves and the fuel injection pumps. The rocker arm. The rocker arm assemblies are mounted on the cylinder head. One of it is connected with the valve and the other with the push rod. When the push rod exerts pressure on the rocker arm, the other end pushes the valve open against the spring tension. So this is the diagram of the overhead valve assembly. We can see the camshaft, the cam follower, the push rod, and the rocker arm along with the valve, the spring loaded valve in this diagram. The piston. The piston is one of the most basic components of an IC engine. The piston with the compression ring seals the combustion space against the crankcase and transmits the pressure in the cylinder to the connecting rod. The piston reciprocates rapidly inside the cylinder. It is attached to the crankshaft through the connecting rod. The connecting rod. The connecting rod transmits the combustion pressure from the piston to the crankshaft and converts the reciprocating movement of the piston into torque. So this is the diagram. The figure shows the piston along with the various piston rings, the fire ring, the compression rings, the gudgeon pin, and the scraper rings. Each type of piston ring has its own functions. The figure here shows the connecting rod. It has a big end and the small end. Valves. Inlet and exhaust valves are fitted on the cylinder head to control the gas flow in the cylinder. These valves are opened out with the help of push rod, the rocker arm, and closed with the help of spring tension. They are also known as poppet valves. Spark plug. It is a high voltage electric device for igniting the petrol air mixture in the cylinder. The diagram here shows the valve along with its various parts. Carburetor. It is a device in the fuel system that mixes petrol and air, atomizing the petrol as it does in the correct proportion and delivers the mixture to the engine in the quantity demanded by the operating conditions. Injector. It is a component of a CI engine which injects the fuel inside the combustion chamber in the required quantity and form. The FIP or the fuel injection pump is a device which supplies the fuel in correct time in the required quantity and in the same interval of degree as per the firing order. Coming on to engine classifications. Engines are classified on the basis of various things. On the basis of ignition system, the engines can be classified as spark ignited and compression ignition. On the basis of working cycle, it can be a two-stroke engine or a four-stroke engine. On the basis of the arrangement of the cylinders, it can be an inline engine, V-shaped engine, opposed cylinder engine, opposed piston engine, radial engine, or a delta engine. On the basis of a starting system, it can be battery started, air started, or manual started. On the basis of cooling system, it can be air cooled or water cooled. On induction system, it can be on a naturally aspirated or a supercharged engine. On the basis of fuel system, it can be a single fuel engine or a multi-fuel engine. On the basis of speed, it can be a low speed engine, medium speed engine, or a high speed engine. And on the basis of the fuel used, it can be a petrol engine or a diesel engine. The figure here shows an inline engine, a V-shaped engine, a opposed cylinder engine, an opposed piston engine, a delta engine. Now, the difference between a four-stroke engine and a two-stroke engine is as flashed. In a four-stroke engine, the cycle is completed in a four-stroke, whereas in a two-stroke engine, it is completed in two-stroke. In a four-stroke engine, one power stroke is completed within two revolutions, whereas in a two-stroke engine, one power stroke is completed in one revolution. In a four-stroke engine, the turning movement is not uniform, and therefore it requires a heavy flywheel, whereas in a two-stroke engine, the turning movement is uniform and therefore requires a lighter flywheel. In a four-stroke engine, less cooling and lubrication is required, and therefore it has less chance of wear and tear, whereas in a two-stroke engine, more cooling and lubrication is required, and therefore there are more chances of wear and tear. More differences of a four-stroke engine versus a two-stroke engine are as flashed. The diagram here shows the diagrammatic representation of a two-stroke engine and a four-stroke engine. Now coming on to the difference between a spark ignited engine and a compression ignited engine. In an SI engine, the speed or the load is controlled by the throttle, which controls the quantity and quality of air fuel mixture. Whereas in a CI engine, the speed or the load is controlled by regulating the quantity of fuel injected. An SI engine works on Otto cycle, whereas a CI engine works on diesel cycle. An SI engine is less efficient as compared to a CI engine. And most of the SI engines are mostly high speed engines, whereas CI engines are mostly low or medium speed engines. An SI engine requires a lower cranking effort as compared to a CI engine. Also, they have a higher exhaust temperature as compared to a CI engine. Further differences are as flashed. Any questions? Thank you.